A Dug Insight base module provides access to the Geometry Volumetrics calculation tool, which makes a fast calculation and is located in the map view. The 3D view is recommended to visualize and help understand the inputs to the volume calculation. The Geometry tool uses a polygon for lateral control and two surfaces or constants for vertical range as seen here with the top and base reservoir. The base extent can be either a horizon or a contact, but not both. Additional surfaces and contacts can be introduced with the Explorationist module. The Volumetrics tool can be used to calculate volumes from multiple surfaces, contacts, and other optional scale factors. The Volumetrics tool provides an easy-to-use wizard to guide you through the calculation, starting with a simple schematic diagram to describe your geometry. Selecting the dual surface option provides the option to select top reservoir, base reservoir, and multiple contacts. I will set my initial contact at 4,000 meters, which is well below the reservoir, in order to capture the gross rock volume. Selecting a polygon limits the lateral extent of the calculation. The results show a volume that matches the geometry results, confirming that the tools are using the same calculation. But note that the Volumetrics tool rounds its results to the nearest 5 significant figures to keep a more realistic level of precision. In addition to a single gross rock volume seen here, depth area and depth volume plots are very useful for understanding the volume change as a function of depth. Instead of using a single constant slice through the data, it is possible to select multiple slices at a specified increment. Here I set a vertical range from 2,900 to 4,000 meters, slicing at an increment of 100 meters. These limits are well outside my reservoir range and will help to estimate the more detailed range for a second pass. The table of results shows zero volume at 2,900 and 3,200 meters, indicating that my true range is within these limits. Adjusting the calculation limits from 2,930 meters to 3,110 meters, slicing every 10 meters, should give a better output. The updated table shows a slice every 10 meters, with corresponding contact area and cumulative volume. The deepest slice shows an area of 0 because it is below the base structure and contacts. The volume for this deepest slice represents the total gross rock volume. For a more visual representation of the data, you can select the table and copy it to a spreadsheet. And with a little manipulation, it's possible to plot depth against area and volume in a graph. These graphs have very characteristic shapes. The area plot value gets bigger, then remains constant, then gets smaller until it reaches 0. The volume plot increases in value as a nice Gaussian curve. The 3D view can be very useful in understanding what causes these shapes. Removing the contacts and the base structure, only the top structure can be seen. Adding in a series of contacts in order of increasing depth clearly shows how the contact area increases with depth for a single surface. When a base structure is included, the contact area of the base structure must be subtracted from the contact area of the top structure, making a decrease in total contact area with depth. The polygon provides a lateral constraint, which for a short depth range in the middle of the structure creates a constant contact area. The volume plot is a cumulative volume, as so can only get larger in value as the depth is increased until the total volume has been reached. In addition to gross rock volumes, original oil in place, stock tank original oil in place, and other calculations can also be computed. Working back through the wizard, I can now add the optional values for these calculations, which can be input as a constant or as a laterally varying horizon. Setting constant ratios for a net to gross of 0.2, porosity of 0.15, water saturation of 0.4, and an oil formation volume factor of 1.2 with an oil recovery factor of 0.6. The calculation can be updated. The report now contains the gross rock volumes and the hydrocarbon volumes. The header states that the oil volume units are millions of US barrels. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with insight.